Good afternoon. So what's energy and why does energy play a central role in the Bitcoin protocol? Those two questions are addressed in the book, and I'd like to go over them with you, explore them with you. First of all, there is a pretty obvious fact that we can all agree on. That's pretty obvious, is that money represents energy. When we accept money as a salary, it's a compensation for our work, and our work is a flow of energy. It's our flow of energy over a period of time. So this representation of energy by money is something that people recognize every time they receive a salary. It's true at the individual level. It's also true at the level of an entire economy, because if we look at this chart, you can see that energy use and GDP, that is gross domestic product. Gross domestic product is a measure of all the money flows within an economy. And you can see they are almost perfectly correlated. So that's also an indication of the fact that money represents energy. This is a snapshot. Over time, as you know, fiat money will be diluted, so it will lose the amount of energy that it's representing. But at any given moment, we have this correlation. So that's for the equivalence, or the equivalence relationship between energy and money. But there is another concept in the science of energy that's crucial to understand, and that's entropy. Entropy is a measure of your uncertainty about the future. It's a physical measure of your uncertainty, of the disorder of your environment. It's observer dependent, like speed. There are other physical measurements that are observer dependent. Energy is not. Energy is absolute, but entropy is relative. So here we have economic freedom. So economic freedom is somehow a measure of the entropy of the entrepreneurs in a given country. And you can see it's also strongly correlated to GDP. It's an even stronger relationship with GDP. So that if you reduce the entropy of the entrepreneurs, you get a richer country. You can see convexity. It's a quadratic convexity here. And the reason why it's convex while the other relationship was linear is the principle of conservation. Principle of conservation states that energy cannot be copied, while entropy, which is hidden information or lack of information, as you know, can be replicated. So because it can be replicated, you see the effect here. If I change the law in a country, the law is immediately known by all the entrepreneurs of the country. So there is this different, that's the key difference between entropy and energy that's crucial to understand. So while in my journeys in the science of energy, I found three beautiful minds that really made crucial contributions to the science of energy. Starting with Antoine de Lavoisier, the 18th century French chemist that first formulated the first principle, that is, nothing's created, nothing's lost, everything's transformed. That's the principle of conservation, and we'll explain later on what are the implications of that. Rudolf Clausius, the German physicist from the 19th century, he invented the concept of entropy and formulated the second principle, which states that entropy tends to increase unless you spend energy to reduce it. And more recently, we have Ilya Prigozhin, 1977 Nobel Prize of Chemistry, that formulated the third principle that has mind-boggling implications, philosophical and practical implications with the science of energy. Okay, so we could define energy as a first step as something that is governed by the three principles. It would be a definition of energy. The third principle, by the way, states that an open system, that is, system receiving energy, will tend to self-organize to maximize its flow of energy. Okay? So that has very interesting applications. We can also try to define energy by its attributes, its properties. So we have not created, that's a consequence of the first principle. It cannot be created, cannot be destroyed. Therefore, it has no beginning and no end. Okay, so it's not created. It's ubiquitous, it's everywhere. Everywhere you look at matter. Matter is a form of energy. Light is a form of energy. In fact, you can see matter only because there is light. You cannot see other forms of energy. We'll see that. It's omnipotent. If you have enough energy, you can do anything. It's intangible, and that's something people don't realize, but as I have this mic in my hand, I'm not really touching the mic, because my atoms are not mixing with the atoms of the mic. So there is a microscopic distance between my hand and the mic. And you're actually levitating on the seat you are seated on. You're not touching it. So it's intangible, you cannot touch energy. And it's mostly invisible unless it's light. It comes in many forms, but we tend to categorize energy between flow and stock. So flow of energy is typically your work. It can be wind, it can be a solar energy. Sometimes people call it renewable energy, although you know now that it makes absolutely no sense because energy cannot be destroyed. So it's just the flow of energy. And you have stocks of energy like fossil fuel, oil and gas. That's a store of chemical energy that you can transform through a chemical reaction that's called oxidation. And more generally speaking, matter is a stock of energy. So that's something also that's not really well understood, but in fact, quarks and gluons, elementary particles, are like drops of energy that will self-organize according to the third principle to form bigger structures like protons and neutrons. And protons and neutrons themselves will self-organize to form the nucleus of atoms. And atoms, again, always the third principle, atoms will self-organize into bigger structures that are molecules, and molecules will form matter. Okay? So now you know that we are all energy. The objects that are around us are also forms of energy. So there are very complex structures. If we go all the way up to the tree of life, we find very complex structures. And the human species is a good example. As you can see, the average person, I don't know why it's called Dave, but whatever, it's made of more than 40 kilos of oxygen atoms. And we are made of billions of atoms. In fact, more atoms than there are stars in the entire universe. So we are dissipative structures, that is open systems receiving energy and transforming it. The word dissipative means some of it is transformed into heat. Heat is a form of energy that's hard to use, but typically a human will convert chemical energy from food, the food is getting, into mostly work and heat. But individuals are part of a larger system, that's a species. And species self-organize, and that's the self-organization results in what we call Darwinian evolution. Darwin was not into the science of energy, so he did not make the link at the time. It took a few decades with Mr. Prigogine to make the connection between thermodynamics and biology. So tigers, for instance, will self-organize, evolve, if you will, to capture the maximum number of preys. And that's why we get tigers today. But doing so, they are in competition with other forms of energy, other species, like lions, like hyenas. So they are well, mostly, I'm not sure about hyenas, because I think they're only in Africa. But the tree of life is more like a bush of life. It's made of many different forms of energy, of systems that go from bacteria all the way up to large mammals. So relatively simple structures all the way up to very complex structures. But there are also non-biological structures. So some people say the living beings are water-based structures, and we have metal-based structures or silicon-based structures. Computers are silicon-based structures. So cars are built by humans, but you can think of cars as a species also that's mingling with another species, the human, to evolve. And according to the third principle, humans will try to make cars dissipate more energy as possible and become more and more effective in supplementing the work we can get from our legs. So you can see it's relatively inefficient in transforming energy, because if it's getting 100 units of energy from gasoline, we're only getting 25 units of kinetic energy at the end. So it's relatively inefficient. The rest is transformed into heat. Again, that's the reason we talk about dissipative structures. But again, think of the ecosystem comprising human species and cars, and you can see that they are effectively maximizing the flow of energy. We can see all the charts show that the ecosystem made of humans and cars is maximizing the flow of energy over time. So technological progress is the other aspect of the third principle. You have Darwinian evolution for the living world, so to speak, the tree of life, and you have technological progress for non-biological structures, starting from a campfire in the Stone Age all the way up to rockets and very advanced technological gear. So that's about energy. So going back to entropy, because entropy is probably the most abstract concept you can think of. It's, again, hidden information or lack of information. So you reduce your entropy by acquiring knowledge. Getting more knowledgeable about Bitcoin is about reducing your entropy with a Bitcoin. So you know more or less, or you think you know more or less how Bitcoin will evolve. While people that don't know about Bitcoin have consider it a high entropy system, so they are kind of anxious about Bitcoin, or it creates, or they are uncomfortable about something that they see as a high entropy system. So generally speaking, if you are in unknown territory, you'll feel less comfortable because for you, it's a high entropy environment. So as we covered the principles, so it's very abstract, but in practice, in everyday life, there are many examples of ways you reduce your entropy, and GPS data is a good example. If I drive through unknown territory, I will save energy, I will save gasoline by not getting lost, taking the shortest route, because I have a GPS receiver, okay? So as a result, I reduce my entropy vis-a-vis my environment, and therefore I'm saving energy. The other way I can benefit from a reduction of entropy is releasing new energy, like inventing something. If I invent something, I release new energy through knowledge, through the accumulation of knowledge. So I take the GPS data example, but I could have taken a monetary system. A monetary system reduces the entropy of its users because it puts a price on goods and services and enables trades to happen. Whereas if you compare the energy that would be spent with barter without a monetary system, you realize that a monetary system is a way to reduce the entropy of the users. So again, the main difference between entropy and energy is you cannot copy entropy. You cannot copy energy, sorry, that's the first principle, while you can copy information, and therefore if you reduce the entropy for one person, you can reduce the entropy for an entire community. It's not a very pretty picture, but I hope this will help you remember this fundamental difference between energy and entropy, because entropy really represents energy. So sometimes it's almost difficult to tell them apart. Okay, so when we think about the monetary system, there are, in my view at least, and I explain that in the book, there are two components to the value of money. One is energy value, the other is social value. Energy value is the energy it takes to issue the money, and the social value is derived from the size of the ecosystem of its users. So for instance, with proof of stake coins, you have only the social value of money at play, okay? For instance, Ethereum has a large ecosystem around it, therefore it has some social value, but it has zero energy values. Fiat money has some energy value because it represents the energy of the borrower, that the borrowers have promised to repay the loans that are, because as you know, fiat money is issued as credit to borrowers. So when they borrow, they promise to repay with their work, so there is a promise of energy. And that's why we can categorize money in two kinds. One is proof of energy money, like Bitcoin, or it's promise of energy money, like fiat. And proof of stake, interestingly, is a kind of hybrid of proof of energy with zero energy. So with zero energy, we have social value. We don't have energy value, okay? So that pretty much concludes my presentation. I'm on time with the time that was given to me. If you want to further explore these questions, I'll be at the BTC Plan B network booth at the end of the expo show. It's on the left as you exit the expo, and they're selling the book. So I suggest you get yourself a copy, and I hope we can continue the conversation to talk about this fascinating subject of energy and money. Thank you very much for your attention.
Secure your BTC Prague 2026 ticket at the lowest possible price now.